Okay, sample problem number 3. The 2 megagram car is being towed by a winch. If the winch exerts a force, this one, the tension, so it has a tension of this cable, and that the winch exerts a force of T is equal to 100 times quantity S plus 1. So if you notice that the force here is a function of the position S. So basta nga ni nagani kabalo na ta nga ato ang gamiton ani nga as a formula or the derivation is the VdV is equal to AdS. Newton on the cable, where S is the displacement of the car in meters, determine the speed of the car when S is 10 meters, starting from rest. So, what pilang speed ni car at 10 meters na nga travel starting from rest. So, initial velocity then is 0. So, money ang given, mass of the car is 2 megagram. Velocity is starting from rest man daw at distance is equal to 0. It means that V is equal to 0 at S is equal to 0. And then we were asked, what is the velocity kung ang iyang distance na is at 10 meters? So we were given a force, T is equal to 100, quantity S plus 1, and Newton. So we know that the acceleration moves to the right. Okay? So we have yes, it moves to the right. So say buhato na to ani. We have the V, we have the con. So 2 megagrams is just equal to 2,000 kilograms. So dali na lang kaayo ni siya no pag solve because minimal ato ang problem. So the object or the car moves only to the right. Therefore, let's say that is the x-axis. Summation of forces along x just equal to max. So may buhato na to ani. So summation of forces along x. So atong force along x, we have the tension here. That is 100 times S plus 1 is equal to the mass of the car, that is 2,000 kilograms times the acceleration. We were asked about the velocity. So we know that the acceleration and velocity has relationship. May pa sila na relationship. So we have the acceleration along x, or let's just say a na lang kay maura mong gyapon usara man ato ang i-analyze dire. So that is equal to 0.05 S plus 1. So the acceleration then is not constant. Therefore, we cannot use the constant kinematic equation. We use another equation. So it is a function of S. If you remember, di ba nga, si acceleration o si velocity ato itong gi-equate in the kinematic equation discussion, we have come up to the formula the velocity times the derivative of the velocity is just equal to the product of the acceleration and the derivative of the position or the displacement. Substituting the value of A here, you have V dV is equal to 0.05 S plus 1 ds. Integrating both sides, so from starting from rest, so the lower limit if the velocity is 0 to V, and then starts from 0 again to 10 meters nga distance. So this becomes a 1/2 V squared from 0 to V is equal to 0.05 over 2 times quantity of S plus 1 squared from 0 to 10. So makancel ni, we can just write it as V squared from 0 to V is equal to 0.05 S plus 1 squared from 0 to 10. So applying the limits, we have V squared minus 0 squared is equal to 0.05 times, so S plus 1, you have 10 plus 1 squared minus 0 plus 1 squared. So we have here V squared is equal to 0.05 times 11 squared minus 1 squared. We have V squared is equal to 0.05 times 11 squared minus 1, 6. And then the square root of the velocity. So the square of the velocity, we have just then we have that the velocity to the right is just equal to 2.449 meters per seconds. So this is the answer to sample problem number 3.